If this is an equation, then the left-hand side has to be equal to the right-hand side. So that component equal component. So the real component will be equal to the real component, and the imaginary component will be equal to the imaginary component. So what does that mean? This implies x minus 2 must be equal to what? What's my real component? X minus 2. A plus bi. Remember a plus bi? A plus bi, right? That's your a. So x minus 2 must be equal to negative 2. Can you solve for x? X equal x equals 0, right? Makes sense, right? If you plug in 0 for x, what do you got? Negative 2 plus 3i equals negative 2 3i. It makes sense, right? And we don't have to do the imaginary part. So let me draw a conclusion. So that conclusion is this. No remark, maybe remark. A plus bi equals c plus bi di. C plus di, where a, b, c, d are real numbers. If a equals c and b equal d. So the real component equal the real component, and the imaginary component equal the imaginary component. Just that simple. I'll give you an example of complex number. Number 1, I say that, well, let's say 5 plus 2i is a example of a complex number because why? Why it's a complex number? Because it's like the definition said, right? A plus bi. Right? Because you have a and you have b and you have I. I also claim that number 3 also, any number, any real number also a complex number. Why? 3 I can rewrite it as 3 plus 0i, right? So there's your real part and your imaginary part right there. So this implies any real number is also a complex number, which just makes sense. Look at the picture I draw up here. The complex circle encloses everybody, right? Everybody is a complex, can be written as a complex form. What about, all right, you guys tell me this. What about, I claim that 5, I don't want to say 5, 4i is also a complex number because 4i I can rewrite it as what? In terms of a plus bi, I can rewrite it as yeah, 0 5, right? There's your a plus bi right there, right? As long as you can write it as in form a plus bi, it's complex, right? And because of that picture, a complex number, any number is a complex number. Even 0, right? 0 is 0 plus 0i. Maybe I put it here. 0 is same thing, 0 plus 0i. So even on your answer, if you have somehow your answer is say 10, and I ask you to write it in standard form, meaning a plus bi, then you don't write 10, you write 10 plus 0i, right? All right, so let's see some more example. Now you simplify. See, that's why we learn about radical. Now you're not allowed to say not a real number anymore because you know about complex number. Square root of negative 25. Tell me the first step I would write this. What do you think I would write? I would split the negative, right, with square root of negative 1 times square root of 25. Or if you want to, you can just go ahead and turn it into an I, which is I times what square root of 25? 5. Or you want to say 5i, right? You guys do numbers 2. Oh, I'm not done yet. Oh, my bad, my bad. I'm not done yet. How should I rewrite 5i? Huh? Yeah, 0 plus 5i. It had to be in a plus bi form, right? Because it's complex. Okay. Square root of -7. You kind of like my new background? It's lighting. I thought it's less, more time. Yeah. Very good, very good. Well, people got it right. So I'm gonna skip the first step. So it's gonna be equal I root 7, right? I can just rewrite like that. And then 0 plus I root 7. What about square root of -18? How would I rewrite this? Well, first step, I root 18, right? I'll give you a point just to say do that. Can you simplify root 18 furthermore? Somebody said what? Right? And so what? So this one is 3. So 3i root 2. Or 0 plus 3i root 2. You know, it look ugly. Isn't that wrong? Just for me, I'm just kind of being anal about things. 3 root 2 times I. You know what? Yeah, let's put the I at the end. Just agree on that. Put that. Just be careful. Please be careful when you write the square root. Do not include the I under the square root. So it looks like A plus BI. Let me check if I can do this on a calculator. Mode. Oh, okay. All right. So square root of. All right. On your calculator. I'm not sure I can. On your calculator. I don't think it's. Does it record if I change screen? I don't think so, right? I want to show this here, but never mind. I use this. If you go to mode, second, quit, see that second and then mode, second mode. I'll just go mode, just go to mode, go all the way down. You see real number and A plus BI and then R to the E, but don't care. I don't care about R. I want to put the cursor over A plus BI and press enter. And then second mode to quit. So that's okay. You have to have a TI-84 though. You don't, you can watch the video later. Now I want to evaluate square root of negative 25, right? So second square root of negative 25. The negative, you should use the opposite sign. Not use the spread side. It's two different things. The opposite side. Press enter, what you got? Bye-bye, right? Bye-bye. What about square root of negative 7? Well, it's not gonna give you, but you can check, right? You can check your answer. Okay, I know square root of 7 is that, so I must have the right answer, right? So you can check your answer on your exam, but of course you have to show work. So I show you how to check your answer, but again, you gotta show work. Good deal. All right, so now we add and subtract complex number in standard form. It is much like adding or subtracting like term, right? We add or subtract the real parts, then add or subtract the imaginary parts. And your final answer should be in standard form. What does that mean? That means I want you to write it in A plus BI form. I'll do the first one, and you gotta do the last two. You gotta do number 2. So 2 plus 7i plus 4 minus 2i. I just remove the parentheses, okay, because the plus nothing changed. And then combine like term. What do I have? 2 plus 4 is 6, right? And then 7i minus 2i is 5i, right? You guys do number 2. And that will be your answer. Let me box it up. Oh, nobody on. All right. So a minus 4i, but then there's a negative in front of the parentheses. So you kind of distribute that -1. So it'll be -1 times 2 is -2. -1 times -i is positive 1i or positive I. Combine like term. 8 minus 2 is 6. And then -4i plus I is -3i. Okay. Number 3, what do you think I should do first? Well, I cannot add root -8 plus root -32. What I can do is I can, well, this one I should have said simplified. I should have said simplified. Right. Okay, simplify root -8 for me. We, first will be I, root 8. I root 8, I can simplify furthermore. I times root 4 times root 2, right? Or if you rearrange it, it will be what? Yeah, 2i squared. Maybe I'll just rewrite like that. 2i square root of 2. Okay. You know, I'll rewrite again one more time. 2 square root of 2 times I at the end. And then simplify the root -32. Again, I root 32. Root 32 is 16 times 2, right? Which is 4i root 2, which is 4 root 2i. Can I be able to add these two together? Are they like terms? Yes, right? They like terms. Well, they have I, so that's good. But then even the imaginary component, this right here, they also alike, right? So if they like term, how do you add? You add what? What do you add? Yeah, you add the coefficient, right? Remember, if for adding and subtracting, if it like term, for radical, you add a coefficient. So it's gonna be 6 root 2 times I, and then standard form 0 plus 6 root 2 times I. Right. They're not difficult. As long as you follow step by step, you should be okay. You guys try number 4. Number 4. It's very much like number 3. In the meantime, I'm gonna take attendance. Chica. What is it? 7. 7. She got 60, so must be right. Very good. Okay, because I think now. same answer. Give yourself a bonus check mark. All right, so Corey, tell me how you simplify root negative 27. Good. Which is yeah. Yeah. Right, thank you. Kobe, tell me how you simplify negative root 48. Good. Good. Thank you both. And then you add together, you got 7 root 3i. Or better yet, 0 plus 7 root 3i. Very good. You know that you can check with your calculator as well. Right, so for example, let me go back to the example 1. Can you read for me, Tyler? Okay, so thank you. First of all, you have to have your mole in A plus BI. You gotta check your mole, okay? It has to be in A plus BI, not real. Otherwise, I'll give you not real number or error in domain. Quit. Go to mode. Yeah. Oh, you don't have that. I don't think you can use that. Oh, that. Okay. Yeah. So mode A plus BI, and then quit, and then read me the first one. Number 1, like number 1. The very first one. That's number 4. Yeah, number 2. Okay. 2 plus 7. Oh, you guys know where the I is? Right at the bottom right there. So second decimal. Second dot I. Go out there and let's plus parenthesis. What is that? All right, thank you so much. 2. Wow. The answer, right? And you can check with number 2, but I'm not gonna go in. I'm not doing that. Let's check number 4. You guys got the same thing? Do you have the same thing I do? Oh, second decimal. The little I in blue. Oh, yeah. You need the second. Number 3. Let's check number 4. Number 4. Maybe I can pull it up. No, I can't. Can you tell me what number 4? Thank you. Okay, it might be not gonna give you because it's irrational. But you can check, right? What did you have? Well, what did you have? You have square root of you have 7 square root of 3. So your answer must be what? Just if you say 7 square root of 3, it should be what? 12.1243, etc. Right? So you know that you got the right answer. They need to fix this. They need to turn it into a. Okay. Now you can multiply or divide complex number. We talk about multiply first. So for multiply a complex number, first, either you FOIL, if you have 2 binomials, multiply together, you FOIL. If you have a number, multiply a binomial or trinomial, you distribute, right? So FOIL or distribution. Then change I squared into -1, because I squared equal -1. And then write your answer in standard form. Standard form mean A plus BI. Okay, so the first one, distribute, right? First one is going to be distribute. So if I distribute the 2i into the 3 and then 2i into the -3i's, 2i times 3 is 6i. 2i times negative 3i will be negative what? 6i squared. And I squared equal negative 1. That's equal negative 1. So negative 1 times 6 becomes what? Positive 6, right? Or 6 plus 6i. Tell you what, whenever you see an I squared, you just change the sign in front of that number and get rid of I squared.
The square gets rid of the I.
Hmm?
The square gets rid of the I. But then you gotta change whatever.
Yeah, because I squared is negative 1. So if you have negative times some sign in front of it, it's going to change the sign, right? So what I'm saying that whenever you see I squared, just change the signs in front of that number. Get rid of the I squared. You guys try number 2. If I can pull up something cool from last time when I go to Greenfield Village. Have you guys been there? The Henry Ford Museum? Yeah.
Into the Henry Ford Museum.
Yeah. It's huge collection. I think it's the biggest collection of cars I've ever seen, which is great. When did you go, Corey? Long time ago. Okay, you may miss something. I'll show you guys what you missed. Stay co-host. Got it. What do you have? Oh, let me show you what I got here. All right, so I think there's a train in front of. There's the big. Sorry, there's a big train, right? There's a big train. Got there. It's called. How do I pronounce that? Allegheny. Thank you, Mike. Allegheny locomotive. See how I don't think you can see how heavy that thing is. It's roughly 600 tons. That is heavy. He asked me that is heavy. Well, back in the day, they built everything with metals, right? There's no plastic. Car nowadays is weak. They all plastic outside, but car back then, they all wrap around metal. So same thing with locomotive. They all metal, so they heavy. So they use this to transport troops, military troop, prisoners, wounded soldiers, whatnot. So this one right here, I forgot what the name of this thing. Come on, I don't want to. But it has to do. It had to do something with manufacturing electricity. So back then, how do they?
Like hydroelectric turbines.
Yeah, it's like it had to do something with water. These cars, they allow us to try it on. Oh, this exhibit. This is new one. So Corey, if you travel back then, you probably miss this new. I think it's pre-pandemic. I had a chance to go with OCC chair. They invited me here, but it wasn't official then. It was in the backstage. So they invite us come and just ask us about opinion and whatnot. But now they actually put out in the museum. It's pretty cool. It's a lot of math stuff. I don't think you can read this, but I took a bunch of pictures. It's pretty cool.
Is that where they had the Mobius loop thing too?
Yeah. So this so let me go to the Mobius. right there, the Mobius band. So there's a thing right here, the red thing right here. It's gonna go around the Mobius. Tracing around Mobius. Let's go back to the same place, right? We did that before. And here's some fact about the Mobius strip. Kobe, I think the last time you told me about something. Yeah, right? Is that what you meant? Yeah. Yeah, I didn't know that. It's pretty cool. I'm gonna try to experiment it on my own. So it's pretty cool. Do you guys, anybody take statistic? High school. Do you guys talk about normal curve, right? The bell curve? No. Okay. Anyways, it's a bell curve. Like IQ score. Most people what? So that means what? Most people. So say from 80 to 200. So most people in between 100. Like that's the average for me. Some people are very smart. Some people are very smart. But not many. Right? But most people here in the middle, around 100. This history stuff. Pythagorean, the Pythagorean. I believe what it is. It looks like fractal to you, does it? The one right here, right? Fractals, just spiral. This is probability. I'm not gonna talk about this, but it's had to do something with sample size. This is a history of math. It's I record in 5 minutes, I believe. It's from 1200s to the present time. Right, so is that it? Conic section. We're gonna talk about conic section at the end of the semester. Right. So conic section, I'm not gonna ruin the surprise for you, but we'll talk about it, and I don't have time either. But that's conic section. I think that's all I got. Stop the sharing. Stop the sharing. So if you have a chance, got it. Go visit your museum, Henry Ford Museum. I think it's the biggest attraction. And then there's the Greenfield Village. All right, back to reality. What you guys have for that one? Taylor, you wanna volunteer?
I just distributed the layer 3i to both.
So be negative. Mhm. Mhm. And negative 6i plus 12, right?
And then I got negative 6 plus 12.
Negative 12 minus 6i, right? I'm sorry, positive 12 minus 6i. Just change thing around. Yeah. Do not distribute. I'm sorry, do not factor. Like, I know it's tempted. Like, oh, I gotta factor. There's 6 and 12. But we want a plus bi. I don't have time to do all of this. We do it again next time. Do it again next time. Okay, so let's talk about give me a few more minutes. I'm gonna talk about the exam plans. I messed it up. I'm so sorry. But I think it's a good news for you because I messed it up. So let me share my screen here. I want to do an iPad or I want to. Would it be okay if I ask you to watch a video? I'm gonna record some video. I ask you to watch it at home. I apologize. Summer break, but I promise it will be short. So exam 2 will be 8.5, 8.6, 8.8, and 9.1. Now 8.8 is today, and we're not even finished. 9.1 is easy. I promise 9.1, we already did this. It's just mostly review. Right, 9.1 is solving equation. quadratic equation, or you can factor and then 7 equals 0. Very easy stuff. So what I'm going to do is, today I'm going to record finish 8.8. And then hopefully I'll be able to record 9.1 as well. And I want you to watch 8.8 and 9.1 at home. Okay. It'll be short. 8.8 probably take me 10 more minutes, and then 9.1 another like 20 minutes. So it'll be short. Your exam will be from 8.5 to 9.1. See how I messed up. I got 2 days. So I apologize about that. But the good news is your exam will be short.
Next Monday.
Yeah. No, next month. Yeah, next Monday. You're right. So Wednesday, Tuesday, Thursday, we don't have class. Yay. Take some time off, travel, and go wherever you want to do. Monday, we have exam 3. And it will be in person. Okay. Oh, about the extra credit, I figured out something. Well, I'm going because exam 3 is gonna be, I believe it's gonna be easier than exam 2 because first it's short, right? So what I'm going to do is I'm going to add up your exam 3 score and exam 2 score and average it out. If it's higher, then I'll take that number for your exam 2. Does it make sense? If it's lower, then I'm not gonna do it. Right. Is that okay? All right. So don't mess up your exam 3 because it's determined your exam 2 fate as well. Right. We'll talk about it, Kobe. All right, have a good weekend. Enjoy your break, and I'll see you next Monday. And watch out for just watching out for my video coming up next.